Alright, hello, welcome back. We want to talk about structs today, and really in the object-oriented programming environment we live in today, we don't think about structs. I mean, we use structs a lot, but we think about structs from an OOP context. I wanted to say that this is kind of the development in C languages to go from basic variables to what would eventually become object-oriented programming that we use today. And structs are still valuable. It's just sometimes we look at them from the perspective of OOP and not from the perspective of variable assignments and where they came from. What I want to show first, so I created a file called chapter 9 CPP. I'm going to save that. And what I wanted to show is how I would represent a student using basic C++. So we're going to include, I need to include IOStream at this point, but now I'll come back to that. I'm going to use namespace std right now, and I'm going to do that. And I just want to show you that I would put in like a string name, so I do need to include string. Alright, and yes. Okay, so I use string name. I could use the age as an int, and I could have like a GPA, so double GPA, right? That's kind of messy though. What if I wanted a collection of related data that would function as a student and hold all these values? Well, I mean, in modern languages like Java, we might use an object. But in C++, we can use another structure called a struct, and it lets us bundle multiple pieces of data under one name. So instead of having this under main, I can explicitly call struct. So I can say struct student, and I can have these pieces of data inside that student. So that works. Those are all attributes of the struct student. And now we have a custom data type called student. We've declared that as a data type, and I can use that data type here in our main method. So I can say student s1, and I can say the s1 name. It's a dot notation call equals Alice. S1 age equals 20. S1 GPA equals 3.0, right? And I can call out each one of these parts of the struct, right? So we have name, because this is already typed, I'm going to go ahead and just kind of copy this line of code down and just kind of change it for age and GPA. Okay. Each student variable can now store all three values together. All right. Now you can also initialize structs with a constructor-like syntax. So for student S2, I'm going to make it a constructor-like syntax. So I can say student S2 equals, and we'll say Bob. I don't know why I can't say Bob today. Bob. His GPA, his age is 22, and his GPA is 3.5. Alright, and I'm going to just copy all of this down for student 2. And just for the purpose of making everything look normal, we'll say student 1 inline and student 2. So we will just copy this down. And really I'll put another, we'll just say student 2 here. We want another inline at the end of this, so I'm just going to go ahead and put \n for a new row. And we'll compile this now, and we'll see what happens. So G++. Save the file. G++ chapter 9.cpp-o chapter 9. Yep. So you see inline is going to come from that IOStream library. I said we weren't going to need it, and then I made some other parts of the code, so we are going to need that IOStream. Obviously, I'm sending stuff out to the console. Okay, so let's bring the IOStream library in, and we will go ahead and do that. And okay, that's because I said GPA here instead of GPA. And also, you might notice that I did not say S2 in my code, which we'll fix right now. Okay, cool. That should fix the problem. And this acts as a functional statement, so the struct does need a semicolon. Alright, and there we go. So let's go ahead and clear out our terminal window by using the clear command. And then I'm going to period / chapter 9. You can see now we have Alice and Bob that have been created as students. And this is clean and concise. As long as, so we now have a struct that works, that holds all these different data types together as one functional object. So it has a string, an int, and a double, and it puts that data together in one user-defined data type that we used here, a student. And this constructor concept allows us to really make it even more concise. Just make sure the order matches the struct definition, right? And we can also pass in structs as functional parameters. So you see how we have this printing thing that we've repeated. Anytime you see duplications in code, that's probably a problem. So let's go ahead and create a print student function. And we're going to pass in a constant student and a pointer to that student, and that's going to be the functional header. Let's implement that function below, and when we do that, literally we can copy down this here. Let's put that inside of our print student method. I can now take out the ones and the twos because we are using s as the pass parameter. Okay. So we have student 1 and student 2 that have been created. I can print both of them by calling print student and passing in s1, and print student and pass in s2. Right. With one minor exception, I do want to, in front of name, do that \n. Actually, yeah, we'll just do \. Let's do it this way. Alright. We'll output student and there in the front of that we're going to put that new line command. Okay, and when we do that, now you can see, got to compile it first. on, sorry about that. Sorry about that. If you saw any glitches in the video, it's because I had internet downtime for a second. Either way, we have this error, and the reason we have this error is because I've actually called the I've called student here before I defined student. So it's looking for student memory and it doesn't exist. So we're going to move this print function header down, and that'll fix that error here in the code. Now we should be able to compile this, and we should be able to run this program. So remember, this is a functional programming language, and you have to make sure that we have everything defined properly and called properly, and that way it looks a little bit like Python if you've had some experience with Python programming. So that works. So we can also store multiple students in an array. So let me do a student class list in our main method. So we have student 1, student 2. Let's go ahead and create an array of students, and we're going to do that by having student class list 3 elements of this class list, and that's going to be equal to, and we will just put in 3 different students in an array, and I'm going to come back and flesh this out. So for the purposes of this particular statement, we're going to say our first student is Diana, our second student is Emma, and our third student is Eli. And we will say Eli is 29, Emma is 25, and Diana is 19. Sorry, 19. And Diana's GPA is 3.9, Emma's GPA is 3.2, and Eli's GPA is 3.6. Alright. I can also print every element in these students. So we basically, in this class list, we've created an array of 3 structs that are students, and I can print that by just saying, let's go ahead and come down here, and I can say this. I can use a for loop, and I equals 0, I is less than 3, because there's 3 students we're looking at, I plus plus, and we are going to print student, and we are going to look at class list at I. Okay. That's a lot better than using parallel arrays, right? And I'm just going to show you that this does functionally work. I will call the method, and you can see that running. So now we have these 5 students. We have Alice that we originally declared, we have Bob, we have Diana, Emma, and Eli. So everything works. Let's do one more thing, and that is simply by modifying the elements in the array. Sorry about that, I just dropped my water bottle. We're going to modify the structs in the array, and we can do that simply by jumping in and changing things. Give me a second to get my life together. Okay, so let's modify the structs within a function, and I'm simply going to create another function that is give bonus. So let's come up here and say give bonus, and I'm going to point to a student. In this case, we're not going to make it constant because this particular student is going to be modified. So we are going to modify these students in this function. Because there's modification, we're going to still pass it by reference because it's going to point to the same struct, but we're going to not make it final. So we're taking that constant keyword off. We are going to look at the GPA, and we're going to add 0.1 to the GPA. If the GPA is greater than 4, then we are going to set the GPA equal to 4.0. Okay. So let's go ahead and give everyone a bonus, and let's actually do something really interesting here. Let's make Eli's GPA 4.0. Right? Now let's go ahead and show you that I can give a bonus to everybody in the class list first. Right? So I can say, let's go ahead and do this. Let's give bonus to S1. And then let's give bonus to everybody in the class list. So we have that same kind of for structure. In fact, I'll just copy it. Let's copy this for structure here. Take that same for structure, and we are going to give bonus to everybody in the class by just saying give bonus to class list at I. Okay, so we've given a bonus to S1, we've given a bonus to the class list, and I will go ahead and say, we're going to copy it all down, and we're just going to say after bonus in after bonus and I'm going to move these lines of code down. I gave a bonus to S1. So we're going to move those lines of code down, and I'm going to go ahead and run this code. Now let's look at what happened. Alice had a GPA of 3.1. She now has a GPA of 3.1. Dana had a GPA of, let's go open our code and look at it. Dana had a GPA of 3.9, it now says 4.0. Emma had a GPA of 3.2, it now says 3.3. Eli's GPA stayed at 4.0. Okay, the interesting thing is we also gave a bonus to S1, and we printed S1, and I did not see the bonus, the GPA change. So that's because we gave the bonus, if you notice, before our initial print. So let's go ahead and move that line of code down below. To here. Yeah. We need to print first and then get the bonus. That's what we want to look at. Okay, so let me run this code again, and it should work this time. Now you see it. We have Alice has a 3, and now she has a 3.1. So this did work. Alright. So passing by reference lets us update the original struct. And it might be important right now to just address this. Passing by value means we pass a copy of the value of the variable into a function. Passing by reference means we pass a reference of the pointer to that object. So we're modifying the same object when we pass by reference. When we pass by value, we're only modifying the copy, and the original doesn't change. So it's very important that we pass by reference, and we need to pass by reference. Here's what we covered today. Structs bundle related variables. Use dot notation to access the fields. Use initializer lists to simplify the setup. You can pass structs by reference, and do so when you're modifying. Use the constant structure for read-only function access. Array of structs make record keeping clean and efficient. That's it for now. You should have everything you need at this point to wrap up this week's project. and we will see you later in future videos. Thank you.